Another favorite tool of physicists to explain activities and position and time and other physical phenomena is a graph. So we're going to take a graph where on the x-axis we plot time and on the y-axis we plot v. And as always, for a good graph, you label the axes and you also put what units you're dealing with. So I have a blue line here, which is representing the velocity at any point. How do you know that the velocity is constant? Well, let's look at the y value, which is velocity right here. It stays constant no matter what time I have. The velocity doesn't change. So we say that a horizontal line on a velocity time graph means that the velocity is constant. Here's a slightly more complex graph of velocity versus time. So let's look at the graph first. We have the y-axis is velocity, and it's correctly labeled in meters per second. Time is labeled in seconds. And we have this blue line which demonstrates the velocity of this object at any time. 3 questions for you. Where is the velocity increasing? Where is it decreasing? And where is it constant? Please discuss with your groups. And go ahead and hit pause on this, and I'll wait a couple seconds and then come back with the answer. Okay, let's look over here. Over this interval, this line keeps going up as I move forward to the right in time. So this line here represents an increase in velocity. This one here is just like the previous slide. It stays horizontal, so velocity stays constant. Over here, you can see velocity going down, 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 so velocity is decreasing, and it's 0 at this point. This is the tricky part. You think it's just getting smaller here because it's a negative number. However, let's look at the values here. This is -1, -2, -3, -4. Your velocity is actually increasing in the negative direction. Remember, velocity is a vector. And then, so in other words, 0, 1, 2, 3, 4 meters per second in the negative direction. So velocity is increasing. And then over here, once again, we're level. Velocity stays constant in the negative direction. We're now going to find another way to find average velocity by using the graph. And we're going to take 2 approaches. In this case, where I have the same velocity the whole time, at any time, again, I have the same velocity. You just go to a time, you go here, you see it's 1 meters per second. When that's the case, your average velocity is just equal to your velocity at any point. Now, in the second case, B, you can see the velocity increasing in a straight line, leveling off, then decreasing in a straight line. In this case, when we want to find the average velocity in any time interval, we use this formula here. And again, this only works if your velocity is increasing in a straight line or decreasing in a straight line. You take your initial velocity, you add it to your final velocity, and you divide it by 2. This is very similar if you're asked to take an average of 2 numbers. You just add the 2 of them together and divide by 2. Now, this equation will be used for this part of the curve, this part, and down here. But if you have a constant velocity, well, the average velocity is just the same as any point there on the graph. So in this case, the average velocity of A would be 1 meters per second, as it is a constant velocity of 1 meters per second. Now let's use this graph here, B, to find average velocities at various time intervals on the graph. So we're going to take advantage of this formula here, V average equals V0 for your time interval plus the final velocity in the given time interval, and divide by 2, just like we take normal averages. And again, this is only valid when we have a straight line for the velocity. So between 0 and 1 second, we see our velocity goes from 0 to 4 meters per second. So we add those two velocities, we get 4 meters per second, divide by 2, and the average velocity in this time interval is 2 meters per second. Okay, now let's go between 1 second and 3 seconds. So that's this horizontal piece here, and in this case the average velocity is equal to the constant velocity, which is 4 meters per second. We move along to the interval between 3 and 4 seconds. Well, we started at 4 meters per second, wound up at 0, so 4 plus 0 is 4, divided by 2, 2 meters per second is your average velocity. And it's still a positive number, so we're still moving to the right. All of these I should of course put a vector, because a velocity needs a magnitude and a direction. Now let's look between 4 and 5, this interval here. We started at 0, and then we went down to a negative 4 meters per second. So in this case, you sum those numbers, you get negative 4, divide by 2, and you get negative 2 meters per second. And in this case, the negative sign means your object is moving to the left. One more, between 3 and 5 seconds. Well, at 3, that's 3 seconds, we started at plus 4 meters per second. At 5 seconds, which is this mark here, we're at negative 4 meters per second. So 4 plus a negative 4 is 0. So here, your average velocity is 0 meters per second. And this is kind of a special case of a vector. You don't have to put a direction there because it's just not moving. Use the graph to determine the instantaneous velocity of graph A at 2 seconds. Well, we just go to 2 seconds here, go up to the blue line. We find that the instantaneous velocity is 1 meter per second. Use this graph to determine the instantaneous velocity at 2 seconds. You go over here to 2 seconds, you go up to the blue line, and you find that your instantaneous velocity is 4 meters per second. And the plus shows that it's positive and moving to the right. Summarizing this activity, we had two graphs. This top one, graph A, showed a constant velocity object, and graph B showed an object that had varying velocity. So when the velocity of a moving object is constant, the instantaneous velocity is exactly the same as the average. Now, for the second graph, when the velocity was changing, its instantaneous velocity is different from the average velocity. There are times when it may be exactly the same, but it doesn't have to be. In this case, it always is. The instantaneous equals the average velocity. In this case, that is not always the case.